Welcome to Gold Wine, crafted by mmHg, your destination for quality education and enlightenment. Dedicated to fostering learning and growth, Gold Wine offers curated content designed to empower and inspire viewers of all backgrounds. Join mmHg on this educational journey by subscribing today. Cheers to learning and discovery with Gold Wine. What is pressure? Pressure is a measure of the force applied perpendicular to the surface of an object per unit area. Mathematically, it is defined as pressure equals area division sine force. In simpler terms, pressure describes how much force is applied over a certain area. For instance, when you press your finger against a table, the force you apply is spread over the surface of your fingertip, resulting in a certain pressure. Let's consider F applied at an object at area A. Pressure equals area division sine force. The SI unit for pressure is the pascal PA, which is equivalent to 1 Newton per square metre, Nm power 2. Other units of pressure include atmospheres, ATM, millimetres of mercury, mmHg, and pounds per square inch, PSI, among others, depending on the context and field of study. Atmospheric pressure. Atmospheric pressure refers to the pressure exerted by the weight of the Earth's atmosphere at a given point on its surface. It results from the gravitational attraction of the planet on the atmospheric gases. Several key points about atmospheric pressure include variation with altitude. Atmospheric pressure decreases with increasing altitude. As you go higher in the atmosphere, there are fewer air molecules above you exerting pressure downward, leading to a decrease in atmospheric pressure. Units of measurement. Atmospheric pressure is often measured in several units, with the standard unit being the pascal, PR. However, some common units for expressing atmospheric pressure include atmospheres, ATM, millimetres of mercury, mmHg, and pounds per square inch, PSI. Standard atmospheric pressure at sea level is approximately 101,325 pascals, which is equivalent to 1 atmosphere or 760 mmHg. Barometric pressure. This is another term used interchangeably with atmospheric pressure, especially when referring to the pressure measured by a barometer. A barometer is a device used to measure atmospheric pressure. Effects on weather and climate. Variations in atmospheric pressure play a crucial role in determining weather patterns. Regions of high pressure, anticyclones, generally lead to clear skies and stable weather, while regions of low pressure, cyclones, are associated with cloudy, rainy, or stormy conditions. Human sensitivity. The human body is accustomed to atmospheric pressure. Changes in atmospheric pressure, such as those experienced during air travel or scuba diving, can have physiological effects on the body, leading to conditions like ear popping or more serious issues like decompression sickness if not managed properly. Gauge pressure. This is the pressure measured relative to atmospheric pressure. When people refer to pressure without specifying which type, they usually mean gauge pressure. For instance, a car tire might have a gauge pressure of 32 psi, meaning it is 32 psi above atmospheric pressure. Gauge pressure is a type of pressure measurement that is referenced relative to atmospheric pressure. In other words, it is the pressure above the atmospheric pressure at a given location. Here are some key points about gauge pressure. Reference point. Gauge pressure is measured relative to the local atmospheric pressure. For instance, if a tire gauge reads 32 psi, it means the pressure inside the tire is 32 pounds per square inch greater than the atmospheric pressure outside the tire. Positive and negative gauge. Pressure. Positive gauge. Pressure indicates that the pressure is greater than atmospheric pressure. For example, If you inflate a car tire to 32 psi gauge pressure, it means the tire pressure is 32 psi above the atmospheric pressure. Negative gauge pressure, often referred to as vacuum pressure, indicates that the pressure is less than atmospheric pressure. A common example is the pressure inside a vacuum cleaner or a suction system. Common uses. Gauge pressure is commonly used in various applications, such as measuring tire pressure in vehicles, monitoring pressure in pipelines and industrial processes, determining pressure in hydraulic systems, conversion to absolute pressure. To convert gauge pressure to absolute pressure, you would add the gauge pressure value to the local atmospheric pressure. For example, if the atmospheric pressure is 14.7 psi, typical atmospheric pressure at sea level in standard conditions, and your tire gauge reads 32 psi, the absolute pressure inside the tire would be 14.7 psi 32, psi 46.7, psi 14.7, psi plus 32, psi 46.7 psi. Importance in engineering. In engineering applications, understanding gauge pressure is crucial for ensuring safety and functionality. By measuring pressure relative to atmospheric conditions, engineers can accurately assess how much additional pressure is being exerted, which is essential for designing systems, equipment, and structures. Absolute pressure. This is the total pressure exerted by a fluid, including both atmospheric pressure and any additional pressure from the fluid itself. In other words, it is the pressure measured relative to a perfect vacuum. Absolute pressure is a type of pressure measurement that is referenced relative to a perfect vacuum, zero pressure. It represents the total pressure exerted by a fluid, including both the pressure caused by the fluid itself and any additional pressure, or lack thereof, from the atmosphere. Here are some key points about absolute pressure. Reference point. Absolute pressure is measured relative to a perfect vacuum, meaning it includes the pressure exerted by the atmosphere, as well as any additional pressure from the fluid itself. For instance, if you measure the absolute pressure inside a sealed container and it reads 15 psi, this includes both the atmospheric pressure and the pressure exerted by the fluid or gas inside the container. Standard atmospheric pressure. At sea level and under standard conditions, atmospheric pressure is approximately 14.7 pounds per square inch absolute, PIA. This value serves as a reference point for absolute pressure measurements. Applications. Absolute pressure is crucial in various applications, including vacuum systems, measuring pressures below atmospheric pressure, such as in vacuum pumps, vacuum chambers, and space applications. Industrial processes, monitoring pressures in systems where it's essential to consider the total pressure, including both the pressure exerted by the fluid and atmospheric pressure. Barometric pressure. Weather forecasting and atmospheric studies often use absolute pressure, considering variations in atmospheric pressure due to weather conditions and altitude. Conversion from gauge. Pressure. To convert gauge pressure to absolute pressure, you add the gauge pressure value to the local atmospheric pressure. Using the earlier example, if the atmospheric pressure is 14.7 psi, standard atmospheric pressure, and your gauge reads 32 psi, the absolute pressure would be 14.7 psi plus 32 psi, 46.7 psi, 14.7 psi plus 32 psi, 46.7 psia. Units. Absolute pressure is typically measured in units such as pounds per square inch, absolute, psia, pascals, pa, atmospheres, atm, or torr, depending on the specific application and region. Differential pressure. This is the difference between two pressures. For example, the pressure difference across a filter, valve, orifice, or any other component in a system. Differential pressure refers to the difference in pressure between 2 points in a system or across a device, component, or medium. It represents the pressure drop or difference between two locations and is often used to measure flow rates, detect blockages, or monitor system performance. Here are some key aspects of differential pressure. Measurement context. Differential pressure is measured as the pressure difference between 2 points in a system or across a specific component. For instance, in a pipeline, differential pressure might be used to measure the pressure drop across a filter, valve, or other obstruction. Calculation. Differential pressure is calculated by subtracting the pressure at one point from the pressure at another point within the system. Mathematically, del P equals P2 P1, dP P2 P1, where dP is the differential pressure, P2 is the pressure at the second point, and P1 is the pressure at the first point. Applications: flow measurement. In fluid systems, differential pressure is often used in devices like orifice plates, venturi meters, and flow nozzles to measure flow rates. The pressure drop across these devices provides an indication of the fluid flow rate. Filter monitoring. In filtration systems, differential pressure across a filter element can indicate the level of particulate buildup or clogging, helping to determine when maintenance or replacement is required. HVAC systems. Differential pressure sensors are used in heating, ventilation, and air conditioning (HVAC) systems to monitor airflow, detect blockages, and ensure proper system operation. Units. Differential pressure is typically measured in units such as pounds per square inch, PSI, pascals, PA, inches of water column, in WC, or millimeters of mercury, mmHg, depending on the specific application and industry standards. Importance. Monitoring differential pressure is crucial in many industrial, commercial, and residential applications to ensure system efficiency, safety, and performance. By measuring pressure differences, engineers and operators can detect issues, optimize processes, and maintain system integrity.
Thank you.